All right, today we're going to start a new unit on probability. Now first, we want to look at some of our key concepts or key ideas in the field of probability. We're going to look at the different ways that we can list a sample space, which are by lists, tables of outcomes, two-dimensional diagrams, tree diagrams, and Venn diagrams. Now, you may have seen these in maybe different classes before of math or science. And also, we want to talk about the different ideas of probability, theoretical and experimental. We have to know how they are different and how they are similar. But first, we want to learn how to illustrate a sample space. Now, what is a sample space? Well, a sample space is a set of all possible outcomes in an event. So when we're talking about an event, we're talking about the probability of, or we're talking about tossing a coin or rolling a dice or picking marbles out of the bag. You know, something that's going to be controlled where we're going to know what our possible outcomes could be. Now, if we have a coin, we have two different outcomes that there could be. There could be either heads or tails. And when we list our possible outcomes, we want to list them, how many there are. So we could have a heads or a tails if we're flipping just one coin. Now, if we're flipping the roll of the dice, fair dice, we're going to have 6 different types of outcomes. And these outcomes are going to be 1, 2, 3, 4, 5, and 6. Now, rolling a dice and flipping a coin might sound kind of easy just listing them out and knowing what are my different outcomes. But we have to know how to do this in different ways to show that there are different possible outcomes if we do this more than once. So to show the possibility when we are going to toss 2 different coins. So on a 2-dimensional grid. So if we have 2 different coins, we're going to have, we have coin 1 up here, and we have coin 2 over here. All right, and the 2 different types of outcomes, coin 2 could be heads or tails, and coin 1 could be heads or tails. Now, we can either get a heads on coin 1 and a heads on coin 2, or we get a heads and a tails and a heads, or a tails and a tails. So we can see here that we're going to have 4 different types of outcomes. We could get a heads and a heads, or a tails and a tails, and so forth. The idea here is to show that we have 4 different types of outcomes. Now, each of those points represented on a grid represents a different type of outcome. So if we want to go back to our first one, where we listed it, we have our heads and heads, we have our tails heads, we have our heads tails, and we have our tails tails. Okay? So being able to represent this, we can actually see that we can actually see on a grid line that there are going to be 4 different outcomes because there's 4 different intersections because each point represents a possible outcome. Now, later on in this chapter, or later on in this unit, we're going to go and see tree diagrams again. Tree diagrams are going to be great to be able to use to show how probability can be used to show different outcomes later on. So if you have 1/2 a chance to get heads or tails, and then you wanted to roll a dice after that, what are the possibilities of having heads and rolling a 2? Or possibility of getting or flipping tails and rolling an odd number. Being able to know that is going to be, being able to show that on a tree diagram is going to help you to see what's the probability of both of those occurring or both of those events happening. Now here, it's just a little bit more basic. We have 2 marbles, and we're drawing. We have 2 marbles from a bag containing red, green, and yellow marbles, and we want to draw 2 different marbles. So we start off with our bag, and we have 3 different possibilities. We could draw a red, we could draw a green, or a yellow marble right off the bat. So we have we don't know how many there are, so we can't list the probability of what each one would be. But we know that there's 3 different types of outcomes that we could have. Then let's say after we draw a red, we could also draw a red again, a green, or a yellow. And the same goes for green and yellow. After that, we still have a chance of drawing a red, green, or yellow. So being able to see that each branch gives a different outcome, the sample space is seen as red with red, red with green, red with yellow, and so on. So being able to know that each branch will represent a pair of outcomes, so then you can be able to list them out, and you can actually match them up a little bit easier to be able to actually see it visually and not just have to think about it in your head. Now, tables of outcomes. Tables of outcomes are great for surveys or things of that nature where people want to actually see what's the difference between maybe adults or kids or females to males. It's very interesting to see how different people can think. So having a table to gather your data is sometimes can help help sort your data a lot easier. So we have people exiting a new ride at a theme park where asked whether they like or dislike the ride. Find the probability that a random person selected, so random person, we're always going to be random, that the random person selected liked the ride. So if we look at our table, we have 55 kids like the ride and 28 adults like the ride. So if we add up 55 with 28, that equals 83. So we have 83 people like the ride. But how many is that out of? We don't know how many that's out of. So we have to add up all of our different people that were surveyed in order to find out what the actual probability that a person liked the ride. So we have 55 plus 28, and then we can add our 17 plus 30 to get 47, excuse me, 47. So then we add up those two together, and we get 130. So there was 133 people that were surveyed. So now that we have 83 people that liked the ride, and there was 130 people that were surveyed, we can know that there was an 83 out of 130 people liked the ride. So that is about 63%. Okay? So there's a 63% chance that if you ask a random person that came out of the theme park, they liked the new ride. Now, we're going to go into a little bit of a trickier topic. What is the probability that a child and that you selected a child and he or she disliked the ride? So what's the probability that you selected a child and he or she disliked the ride? So now we're not only just looking at this category. We're looking at right here. So we're not just looking at children. We're not just looking at people that liked it. We're looking at the children that disliked the ride. So we have only 17 people or 17 children that disliked the ride out of 130 people that were surveyed. And if you do the fraction, 17 divided by 130 is going to be about 1.13 probability multiplied by 100. It's going to be around 13%. Okay? All right, last one. What is the probability a random person is selected that he or she is an adult or dislikes the ride? So if we go back to our table, and we get rid of all of this. Now, we want to know the probability that when a random person selected that he or she is an adult, so we're looking at adults or the person dislikes the ride. So we want both categories. We want both. We want to have adults and everyone that dislikes the ride. So if we add them all up, we have 28 adults that like the ride. We have 30 adults that dislike the ride, and we have 17 children that dislike the ride. Now, the tricky part is we cannot add the dislike adults twice. Even though it overlaps, we have to make sure that we don't add the 30 adults twice. So that's why we can go by category. We can go by adults that like the ride, adults that dislike the ride, and then we go to children that dislike the ride. So we hit each category. And if we add up that, we get 55. So we get 55. Nope, sorry. 75. We get 75. 75 adults or we selected an adult or a person that disliked the ride. We get 75 people out of 130, which is roughly 0.577%. And if you multiply that by 100, we get to 57.7%. So when we have this word or, we have to make sure that we're going to be taking both categories. We want to be able to have the adults and the disliked people. So we want to make sure that we have the adults and the disliked people. When we have the word and, we're breaking it down. We're going to be having children and those who dislike the ride. So we just want the children that dislike the ride because they have to be in both categories. While the or means it could be in either one. Okay, well, now we're going to go on to the idea of experimental probability versus theoretical or mathematical probability. And the experimental probability is an event, and it's a ratio or a number of times that event occurs in the total number of trials. It's real data found from an experiment or an event. So it's you going out and rolling the dice 10 times and you getting 4 times. it's not the idea like theoretical probability, where if I flip a coin, if I flip a coin 10 times, I should get 5 heads, 5 tails. Where in real life, that most of the time, it does not always happen like that. I can flip a coin 10 times and I'm going to get 6 heads and 4 tails, or I'll get 7 tails and 3 heads. Theoretical and experimental probability can be the same, but they're not always going to be. We have to take into the fact that theoretical probability is the idea of what we think is going to happen, or the chances of what's going to happen, and that experimental probability is what actually does happen. Now, this problem right here is actually theoretical probability, but we could actually roll the dice, roll a 6-sided dice, and actually see what we actually could come out with. But that would be in roll a dice 6 times and see how many 1s, 2s, 3s, 4s, and 5s, or 6 you get. But here, we want to just roll the dice 1 time, and it wants to know what is the chance. Chance, that's going to give you the clue. What's the chance that it's going to actually be getting a 1? So we're doing theoretical probability here. What's the chance that something is going to happen? So I'll give you a second here and try to guess. What are these chances going to be? What's the chances of getting a 6, of not getting a 6, of getting a 1 or a 2, or not getting a 1 or a 2? Okay. So if we roll the dice, we talked about before, we have 6 different outcomes we can have. We could have 1, 2, 3, 4, 5, or 6. And what are the chances of getting a 6? Well, here's our 6. So there's 1 chance out of 6 tries, okay? Out of 6 other opportunities or outcomes that actually could happen. So we have one opportunity of getting a 6, and we have 5 opportunities of not getting a 6, okay? So 1 opportunity of getting a 6 and 5 opportunities of not getting a 6. Those are called complementary events. Where we're going to have an event, where we're going to have 2 events, and where them being together is going to make 1 occurrence, or one where them together are going to make if either one happens, all together with the outcomes, it would make everything happen. So no matter what, when I roll dice, I'm going to get a 6, or I'm going to get not a 6. And the same thing with these last ones, with C and B. What are the chances I get a 1 or a 2? I have 1 or a 2. So or means either one could happen. So I can get a 1 or a 2. So there's my 1, there's my 2. So I have a 2 out of 6 chance, or a 1/3 chance, of this actually happening. Now, what are my chances of not getting a 1 or 2? So it's opposite. It's the whole rest of the set, where I'm going to have 4 out of the 6 chances of not getting a 1 or a 2, which is just equal to 2/3. So I have a 2/3 chance of not getting a 1 or 2, and a 1/3 chance of getting a 1 or a 2. So if you add those together, and when you get something like that, that's how you can figure out if they're complementary events. They should add up to 1. All right, so going over our objectives again. We have to be able to list sample size in various different ways. Now, I know we didn't do Venn diagrams today, but they're going to be coming a little bit later. And we're going to have another little small bit on tree diagrams, going a little bit deeper seeing how they're actually can go, and we can use them a little bit more effectively. But we were able to list, use tables of outcomes, two-dimensional diagrams, all right, and knowing the difference between theoretical probability and experimental probability, because theoretical probability does not always happen when we're doing these experiments and when we are going to be doing these maybe activities in class, and we're not always going to have the dice roll out 1, 2, 3, 4, 5, and 6 in our 6 tries. We're going to have occurrences that happen over again where we can actually roll two times in a row. So just being able to know that and understanding that real life is not always what we always predict is going to happen, but might be the best chances of happening.